NEC section 310.15b4 addresses the neutral conductor requirements for multi-wire branch circuits. This section states that the neutral conductor is permitted to carry the same amount of current as the ungrounded conductors, but the neutral conductor should not exceed 200% of the branch circuit's current rating. A multi-wire branch circuit shares a common neutral conductor between two or more ungrounded conductors. Understanding the current limitations on the neutral is essential for electrical safety and code compliance. Let's consider a scenario involving a 20-amp multi-wire branch circuit using number 12 THHN wire. The question often arises, what is the maximum allowable current on the neutral conductor in this situation? To determine this, we must correctly interpret and apply NEC section 310.15b4. The code permits the neutral to carry the same current as the ungrounded conductors, but it also imposes a limit of 200% of the branch circuit rating. In this case, the branch circuit is rated at 20 amps. Therefore, the maximum current the neutral conductor can carry is 200% of 20 amps, which equals 40 amps. It's important to understand why this limit is in place. In a balanced multi-wire branch circuit, the neutral current is ideally zero. This occurs when the loads on each ungrounded conductor are equal. However, in real-world scenarios, loads are rarely perfectly balanced. This imbalance results in current flowing through the neutral conductor. If the neutral conductor is undersized or subjected to excessive current, it can overheat, potentially leading to insulation damage, fire hazards, and equipment malfunction. Therefore, the NEC establishes these limitations to ensure safety and prevent overloading of the neutral conductor. Now, let's address the specification of 80% of the full load on the hot side, which in this example is 16 amps. This 80% figure typically relates to the continuous load calculation for branch circuits. According to the NEC, branch circuits supplying continuous load should be rated for at least 125% of the continuous load. This translates to limiting the continuous load to no more than 80% of the overcurrent protection device rating, such as the 20-amp circuit breaker. In this specific scenario, the 16-amp figure is relevant for calculating the maximum allowable continuous load on each ungrounded conductor of the multi-wire branch circuit. However, it does not directly affect the calculation of the maximum allowable current on the neutral conductor. The neutral conductor limit is still based on 200% of the branch circuit rating, which remains at 40 amps. It is crucial to differentiate between the continuous load calculation for the ungrounded conductors and the neutral current limit. The continuous load calculation ensures that the branch circuit is not overloaded under sustained use. The neutral current limit ensures that the neutral conductor itself is not subjected to excessive current, regardless of the load distribution. To further clarify, consider a scenario where each ungrounded conductor in the multi-wire branch circuit is loaded to its maximum continuous load of 16 amps. If the loads are perfectly balanced, the neutral current would theoretically be zero. However, if the loads are significantly imbalanced, the neutral current could approach the current on the more heavily loaded and grounded conductor. Even with balanced loads up to 16 amps on each hot leg, the neutral current limit is still 40 amps. This provides a safety margin to accommodate potential imbalances and prevent overloading of the neutral conductor. In practice, it is always recommended to strive for balanced loading on multi-wire branch circuits to minimize neutral current. This can be achieved by distributing loads evenly across the ungrounded conductors. Regular monitoring of neutral current is also advisable, particularly in circuits with significant nonlinear loads, which can generate harmonic currents that increase neutral current. When installing and maintaining multi-wire branch circuits, it is essential to adhere to all applicable NEC requirements, including those related to conductor sizing, overcurrent protection, and grounding. Proper installation and maintenance practices are crucial for ensuring the safe and reliable operation of these circuits. In summary, for a 20-amp multi-wire branch circuit, the maximum allowable current on the neutral conductor, as per NEC section 310.15b4, is 40 amps. This limit is independent of the continuous load calculation for the ungrounded conductors. It's based on 200% of the branch circuit rating to provide a safety margin and prevent overloading of the neutral conductor. Always consult the latest edition of the NEC and a qualified electrician for specific applications and interpretations. Understanding these concepts and the NEC requirements is vital for all electrical professionals. Understanding neutral current limits in multi-wire branch circuits is a critical aspect of electrical system design and safety. The National Electrical Code, or NEC, provides guidelines to ensure that these circuits operate safely and efficiently. One of the key considerations is the maximum allowable current on the neutral conductor. Let's break down the relevant NEC section and its implications. NEC section 310.15b4 addresses the neutral conductor requirements for multi-wire branch circuits. It allows the neutral conductor to carry the same amount of current as the ungrounded conductors, but not more than 200% of the branch circuit's current rating. A multi-wire branch circuit consists of 2 or more ungrounded conductors that share a common neutral conductor. This configuration can be more efficient than running individual circuits for each load, as it reduces the number of conductors required. However, it also introduces complexities related to neutral current. In a balanced multi-wire branch circuit, the current in the neutral conductor is ideally zero. This occurs when the loads connected to each ungrounded conductor are equal. In such cases, the currents in the ungrounded conductors cancel each other out in the neutral conductor. However, in real-world applications, loads are rarely perfectly balanced. This imbalance leads to current flowing through the neutral conductor. If the neutral conductor is undersized or subjected to excessive current, it can overheat, potentially causing insulation damage, fire hazards, and equipment malfunction. To prevent these issues, the NEC sets limits on the maximum allowable current in the neutral conductor. For a 20-amp multi-wire branch circuit, the maximum allowable current on the neutral conductor is 200% of 20 amps, which is 40 amps. This limit is based on the assumption that the loads on the ungrounded conductors may be significantly unbalanced. Even if each ungrounded conductor is loaded to its maximum capacity, the neutral current should not exceed 40 amps. It's important to note that the 80% figure mentioned earlier relates to the continuous load calculation for branch circuits. According to the NEC, branch circuits supplying continuous load should be rated for at least 125% of the continuous load. This means that the continuous load should not exceed 80% of the overcurrent protection device rating. For example, a 20-amp circuit breaker can supply a continuous load of up to 16 amps. This 80% rule applies to the ungrounded conductors in the multi-wire branch circuit. However, it does not directly affect the calculation of the maximum allowable current on the neutral conductor. The neutral conductor limit is still based on 200% of the branch circuit rating. In practice, it is always recommended to strive for balanced loading on multi-wire branch circuits. This can be achieved by distributing loads evenly across the ungrounded conductors. Regular monitoring of neutral current is also advisable, particularly in circuits with significant nonlinear loads. Nonlinear loads, such as electronic devices and fluorescent lighting, can generate harmonic currents that increase neutral current. These harmonic currents can cause the neutral conductor to overheat, even if the fundamental current is within the allowable limit. When installing and maintaining multi-wire branch circuits, it is essential to adhere to all applicable NEC requirements, including those related to conductor sizing, overcurrent protection, and grounding. Proper installation and maintenance practices are crucial for ensuring the safe and reliable operation of these circuits. Understanding the concepts of neutral current and the NEC requirements is vital for all electrical professionals. By following these guidelines, you can help prevent electrical hazards and ensure the safety of electrical systems. Now let's delve deeper into some specific scenarios and considerations related to neutral current in multi-wire branch circuits. One common scenario is a multi-wire branch circuit serving a kitchen. Kitchens often have a variety of appliances such as refrigerators, microwave ovens, and toasters, which can create significant load imbalances. In such cases, it is crucial to carefully distribute the loads across the ungrounded conductors to minimize neutral current. Another important consideration is the type of loads connected to the multiwire branch circuit. As mentioned earlier, nonlinear loads can generate harmonic currents that increase neutral current. These harmonic currents can be particularly problematic in circuits serving electronic equipment, such as computers and servers. In such cases, it may be necessary to install harmonic filters to reduce the harmonic currents and prevent overheating of the neutral conductor. Proper grounding is also essential for multiwire branch circuits. The grounding system provides a low impedance path for fault currents, which helps to protect against electrical shock hazards. The grounding conductor should be properly sized and connected to all metal enclosures and equipment. In addition to the NEC requirements, there may also be local codes and regulations that apply to multi-wire branch circuits. It is important to consult with local authorities to ensure that all applicable codes are followed. When troubleshooting multi-wire branch circuits, it is important to use a multimeter to measure the current in each conductor, including the neutral conductor. This will help to identify any load imbalances or excessive neutral current. If the neutral current is found to be excessive, the load should be redistributed or the circuit should be reconfigured to reduce the neutral current. In some cases, it may be necessary to install a larger neutral conductor to accommodate the increased current. In summary, understanding neutral current limits in multi-wire branch circuits is a critical aspect of electrical system design and safety. By following the NEC requirements and best practices, you can help prevent electrical hazards and ensure the safe and reliable operation of these circuits. Remember to always consult the latest edition of the NEC and a qualified electrician for specific applications and interpretations. The 200% rule is especially important to remember. Many people just assume that the neutral can only carry the same amount of current as the breaker, so it is rated for 20 amps. However, it is actually 40 amps, as calculated previously. This is a common misconception that can lead to dangerous situations. Always double-check the NEC guidelines and ensure that you are following them correctly. This will help you avoid any potential problems and keep everyone safe.